There we go. This is the lesson for my applied math students. We're going to review and do some new examples for chapter 7.6. And here is what we'll start with. Well, first we'll start with this lovely, a high school basketball coach brought in Judy, a trainer from one of the local college teams, to talk to the players about shot analysis. And they used a stroboscopic photograph system to take pictures every fraction of a second so you could see the pathway of the ball. And that's how you work on your shot. Those of you who maybe play basketball at a high level, maybe you've done something similar to this, where somebody who has played at a level higher than you kind of looks at your shot and tells you, you know, you'll get it in more often if you add more arch to your shot, or maybe you kind of overdo it and you should maybe think of a little less of an arch to your shot. But at the same time, the word arch is an a vague and unspecific term. At the end of the day, every shot's a parabola. We can use math to work out something like the arch of a shot, because remember, the highest point, let me go back to the picture for a sec, the highest point on this shot is the vertex of its parabola. So this point here is my h and my k. So we have this lovely equation here, y equals -1 times, open a bracket, x minus 8 squared plus 13. So if we look at that function, and let's just jump down to further on here, what are the characteristics of this graph? Well, this graph here, let's take a look at this graph. So let me cut it out. Well, get out of the way if I can cut it. There we go. Let's play with this. Copy, and let's play with it on this page here. Paste. There we go. All right, what do I know about it? Well, I know it has a vertex of hk. And remember, h in the formula, let's write the formula down. H in the formula is being subtracted. So is this number. So h itself is actually +8. K in this one's added. So if there was a negative here of -0, it would belong to the k. But this is a positive, so 813 is my vertex. So that is the highest point of the shot. The shot is 8, 13, which means that we're 8 feet from where we started. I think we're measuring in feet here, right? Trying to imagine a 13-meter high shot. That'd be kind of high when the basket's only 10 feet high, and 13 feet off the ground. So there we go. That's what we know about this shot. Now we know that the basket, like I just said, the basket itself is actually 10 feet high. So let's pick an arbitrary number. Like, for example, or no, let's not pick a number. Let's say this is the equation of the shot. How far does this student have to be, or this basketball player have to be? Here, let me draw the basketball player. There's his arms. How far does this basketball player have to be for this shot to have a chance of going in? How far does that have to be? So in other words, if the y value, if this point here is 10, what does the x value have to be? So there's the equation. Let me write it down again. If the y value is 10, how much is x? And I got good news for you. We can use Desmos to figure this out for us. So let's graph this equation. So let me just erase this one and sort of start from home. And let's type in the equation. So the equation is y equals -0.1 times, open a bracket, x minus, and that's how good my memory is. What was it again? -8, that's what it was. So -8 and squared, and then, what was it again? Plus 13. Plus 13. Okay, and then I might can kind of move this around a bit and shrink it there so then I can see the whole thing. Oh, you know what I haven't done today? And maybe I should do this, especially since I'm making a video of this now. Don't forget that we can, of course, do this using a TI calculator, right? So using a TI calculator, if turn it on, double check to make sure you're not trying to graph stats and equations at the same time. Nope, stat plots are all off, that's good. So go to my y list, get rid of whatever's there before, and go y equals negative 0.1x, oh wait a minute, sorry. Back up, open a bracket, x minus 8 close brackets squared, and what was it again? Plus 13. And then graph it, and oh, my windows. Oh yeah, I had a window for some problem I was doing the other day where this is in the hundreds. You know, to go to just sort of my general window settings, I can just say standard. That kind of puts us there, and there we go. Oh, that's too big. I have a couple of things I can do. I can try zoom fit, which is zoom 0, or I can just play with it myself. I can see it now. I don't really care about negative, so I could just say negative 1 is probably enough there. Delete that 0. And x maximum of 10 is not far enough, so let's go to 20. Remember, this means scale, so that means counting by ones. Good enough. Now again, I don't care about negatives. What, the ball's going to go through the floor 10 feet down? I don't think so. But I don't like having my grid axis kind of right on the bottom of the screen, so I'll leave a negative 1 just to make my graph easier to look at. And 10's not high enough. The basket itself is 10, so I'm going to go 13. And there we go. And then I'm going to go back to my graph and, oh wait, what? What did I do wrong? Oops. No, zoom. Negative 1. Oh, that was supposed to be a 20. That's why. Sorry. Didn't I hit a 0? Must have missed it. There we go. Oh, there we go. And that 13, you know what? That 13 just, that offends my eyes. I'm going to change that to a 15 just so it has a little bit of breathing room. Nice to give your graph breathing room. There we go. There's the graph. Beautiful. Now, what is it I want to know? Oh, yeah. I want to know how far I have to be from the basket for this shot to possibly go in. And the basket's 10 feet tall. So I want to know how much x is when y is 13, or sorry, is 10. So on this one, no problem. I'm just going to graph, so on Desmos, I'm going to graph what happens when y is 10. And there we go. Boom. I need to be around 13 feet from the basket for that shot to go in. If I tried taking a shot with this arch from further back, I'll be short. From closer in, I'll be hitting the top of the backboard, right? Throwing up a brick. How do you do that on the TI? Basically the same way. Graph a line where y is equal to 10, and then find the intersection point. Now this one's a little trickier. You have to go to calculate, and you want to know the intersection point of your two lines. And yeah, I don't want this intersection point on the left. I want the one on the right. So I'm on a left. Yeah, that's the first curve. I'm on it. Yeah, good. Enter. And then the second curve. Yeah, that's the second curve. And there it is, 13.5 roughly feet. So to answer my question, go back, I would say this shot could be successful from 13.5 feet away. So there we go. So that's the proper arch or the proper parabolic curve for a 13.5 foot away jump shot, which is not very far away, right? I mean, think about it. What's the foul line? How far is the foul line? Is the foul line 16 feet or 20 feet? I don't remember. Basketball aficionados, how far is the foul line from the free throw line? How far is the free throw line from the backboard? Hopefully you're all awake out there. All right, let's do another one. Let's go back to the book. And, okay, so that's one example. Next example is, this is a good example too. Example 1, suppose I had a function like this, and it asked me for the domain and range. So I'm going to go through this example here. So sketch the graph of this thing and tell me its domain and range. Okay, so let's do this. So this is example 2. You don't have to write this down. Just follow along. You can make notes if you want. Paste. Okay, so what's domain again? Domain is, let me get my pen happening here. Domain is, of course, all possible x values. Okay, and range is all possible y values. I think we already have this in our notes somewhere if you flip back in your notes package a little bit. Okay, so this thing is a parabola, and we know, let's make a quick sketch of it. You don't even have to make me a nice graph, just make a sketch. We know that it's a positive a, so it goes upwards. We know that it's a little narrower than usual, because that's a 2, not a 1. And we know we have a vertex at 3, -4. So 3 over and 4 down. Now what does this parabola do? Well, it's going like this and like this. I don't know. You know what? I just realized it's narrower than usual. That's way too wide. So it goes like this. Oh boy, that's terrible again. Let me try that. There we go. Like this. And like, I don't know, like this. Something like that, right? Now, is it ever going to curve around and do that? No, parabolas don't behave that way. This distance between these two arms is always expanding. It's getting bigger forever. There is an x value for on this line for any x number you want. X can be any number, and you'll find a point for that x on that line. You might have to go a heck of a long way left or a long way to the right, but x can be any real number. Remember that from grade 10? That's my domain. We have another notation. We could also write in interval notation that x can be from -infinity to infinity. Again, this is set notation. This is interval notation. Range, can y be any number? No. You see, the y numbers stop right here. So I'd have to say that y is any number bigger than or equal to -4. So my interval would be start at -4, and that's a square bracket because 4 is included in this number. I can't include infinity and -infinity because those aren't really numbers. And I can go up to infinity. Again, this is set notation, this is interval notation. I honestly don't remember what the textbook does. Let's take a look. What does the textbook do? Oh, they probably write it really formally, don't they? Go away, calculator. I'm done with you right now. They do. They probably write it really formally. Let's see. Yes, they do. Oh, my word. Okay, so what this is saying, let me explore this with you for a second. And yeah. They do this as one answer. They put domain and range into one statement. And paste. There we go. Okay, so they put it into one statement and say, you don't have to write it this way if you don't want to. The set of all numbers, that's what that curly bracket is, for x and y, which is, again, the domain and the range, such that, yes, this line has a meaning and it means such that. The x values could be any real number. This is basically, this part is the same as what I set up here. And then they put this part together in the same set bracket. Y is greater than or equal to -4. But they also take the time to say, oh yeah, y is also counting in real numbers. And these R's should have an extra line on them to be extra fancy, but there you go. I'm very happy with you giving me the domain and range as two separate answers. and I don't need the fancy set brackets. Again, we're not a number theory course. We don't have to be super formal. This is applied math. Just communicate the idea and show me that you understand that x can be any number, but y has to be -4 and up. Heck, if you said it in words, I'd give you the marks. If you actually wrote x can be any number, but y must be -4 and above, I'd say there's your domain, there's your range, there's your marks. I'd give it to you. This is, of course, less writing. If you understand the symbols, it makes your life easier, not harder. So there we go. So there's the second example I wanted to do today, just to refresh your memory on domain and range. Then I was going to maybe jump to example, I think it's 3. Yeah, example 2 I don't want to talk about. I'd never ask you a question like that. But I like example 3. No, actually it's not example 3. Maybe it's example 4 then. Yeah, there it is. Soccer. Right now the Brazilian guy and anybody who grew up for at least part of their life not in North America like, why can't you just call it football like everybody else in the world? Well, we already have a sport called football. It involves dressing up in armor and crashing into people and trying to concuss them. That's basically it. It's a fun game. All right. A soccer ball is kicked from the ground. After 2 seconds, the ball reaches its maximum height of 20 meters. So, if t equals time and h equals height, I'm going to say height as a function of time is sum a times t minus h squared plus k. Now you're probably going, hey, wait a minute, what's with all these new letters? Well, hey, this is just y, and this is just x. No big deal. So determine the quadratic function that models the height of the kick. Well, it actually tells me the h and the k. If it's the maximum height of 20, my vertex is in fact 2, 20. So I have height as a function of time is some a coordinate or some a number times t minus 2 squared plus 20. So once again, I already know h and k. It's just figuring out this pesky a number. How am I going to do it? Well, it tells me another point. It tells me it lands on the ground at 4 seconds. So if all of the points in this parabola are some time coordinate and some height coordinate, if it lands on the ground in 4 seconds, what point did it tell me? And I'll give you a second to think about that. It lands on the ground in 4 seconds. What point is that? Feel free to either turn on your mic and say what you think the answer is, or type it into the chat. No, it's not the minimum. This doesn't have a minimum because it has a maximum, right? It can't have both. A parabola either has a minimum because it looks like that, or it has a maximum because it looks like that. And this is me kicking a soccer ball, so it's definitely that. T, okay, so T, what is T? You're right. Somebody said T, and I think I know what you're saying. This 4 is T. So I also know that 4 is an x coordinate, but what's the y coordinate that goes with it? Or in this case, the h coordinate. T is 4, correct. But what's h when t is 4? I'll give you a hint. Read what it's telling you.
Yeah, that's what I'm saying. Get it for yourself, and I'll show me which type
Okay,
one
you've got your mic on there. Okay.
No. I'll take it.
There we go. I muted you until you tell me what the answer is. You can turn yourself back on if you want. So anybody? The first insight somebody told me online was perfectly true. This 4 is a T. What's the H that goes along with it? Read the question and think about it. It lands on the ground. What is that telling you?
Zero.
Correct. That's a point on the graph. It's actually an x-intercept. And it's going to let me figure out my a, because when h is 0, right, h of t, which is just h, when h is 0, t is 4. And there we go. Now I can find a using my basic algebra. 4 minus 2 is 2. 2 squared is 4. Move the 20 to the other side. It becomes a negative. Divide both sides by 4, and a is negative 5. So therefore, my equation is height as a function of time is negative 5 times, open a bracket, t minus 2 squared plus 20. Boom, we just answered the A question. Determine the quadratic function. What are the restrictions that must be placed on the domain? Okay, can time be any number? Well, not really. I would say that my domain is, domain is that time has to be greater than or equal to 0, right? There's an instant when I kick the ball, my foot connects with the ball, that'd be time 0. And then after that, time keeps going. But wait a minute, time goes to 0, and does the ball stay in the air forever? Only if I'm like the best soccer player that ever lived, and somehow supernatural, I could kick the ball so hard that it achieves escape velocity, and it then orbits the Earth. And there you go. Time would be infinite. Well, even then it wouldn't be infinite. The solar system won't be around forever. It'll eventually come crashing back. But no, I can't kick it that hard. Nobody can. And actually the problem tells me, when does it hit the ground? 4. So time has to be less than or equal to 4. I can make that one statement. I can say time has to be greater than or equal to 0, but less than or equal to 4. And that's my domain. Right? The ball's in the air for 4 seconds. It has a 4-second, the word I think you'd use is hang time, as a 4-second hang time. You kick the ball, 1, 1,000, 2, 1,000, 3, 1,000, 4. And there we go. That's it. And we know this point is 4, 0. And we know this point, I guess, is 0, 0. At time 0, it has 0 height. And this point here, what was this point? Oh yeah, 2, 20. That's my parabola. Okay, and what was the C question? What's the restrictions on the range? Well, the range isn't going any higher than 20, and we're going to assume the ball doesn't dig into the ground. And I almost combined domain and range and said romaine. I'm thinking about my lunch. There's lettuce involved. Range is that height has to be between the 0 when it's on the ground and the 20, which is the highest it can go. Does everybody get how I'm saying that? Oh, those of you who like interval notation better, 0 to 4, 0 to 20. That's a perfectly good answer, and I'll accept it, but your textbook doesn't give answers that way. Okay, but I love interval notation. I'm a big fan. Don't care which way you do it. C, what was the height of the ball at 1 second? Well, I've got a nice new equation, right? My equation says the height as a function of time is negative 5 times t minus 2 squared plus 20. I would like to know the height at the 1 second mark. So when I would like to know the height of 1 second. So replace the t with a 1. And this is something you did back in grade 10. This is function notation. So my height is negative 5 times negative 1 squared plus 20, which is negative 5 plus 20, because 1 squared is just 1, and the negative goes away when you square it. And so that's 15. Is this feet or meters? I've forgotten what we're in here. Meters. So it was 15 meters off the ground at the 1 second mark. And there it is. Those are the kinds of questions you're going to do in your homework tomorrow. So that we'll stop it there. I'll stop my video. Okay, thanks for watching it.